Now let's start our section 7, which is supervised learning. So in supervised learning, we are gonna start with regression analysis. So regression analysis is a statistical method to model the relationship between dependent and independent variables with one or more independent variables. More specifically, regression analysis helps us to understand how the value of the independent variable is changing corresponding to an independent variable. When other independent variables are held fixed, it predicts continuous or real values such as temperature, age, or salary, price, etc. We can understand the concept of regression analysis with an example. So, suppose there is a marketing company A who does various advertisement every year and gets sales on that. So the table shows the advertisement made by the company is in the last 5 years and the corresponding sales. Now the company wants to do the advertisement of $200 in the year 2019 and wants to know the prediction about the sales of this year. So to solve such type of prediction problems in machine learning, we need regression analysis. So, regression is a supervised learning technique which help in finding the correlation between variables and enable us to predict the continuous output variable based on one or more predictor variables. It is mainly used for prediction, forecasting, time series and modeling etc. In regression, we plot a graph between the variables which best fit and the give data points. Using this plot, the machine learning model can predict about the data. In simple words, regression shows a linear or curve that passes through all the data points on the target predictor graph in such a way that vertical distance between the data points and the regression line minimum. The distance between points and the line tells whether a model has captured a strong relationship or not. So the example of regression analysis can be prediction of rain using temperature and other factors, determining marketing trends, prediction of road accidents due to the rash driving. So there are some terminologies which we will discuss throughout the session. So let's discuss these terminologies. First one is dependent variable. The main factor in regression analysis which we want to predict or to understand is called the dependent variable. It is also called the targeted variable. Independent variable. The factor which affect the dependent variable or which are used to predict the values of the dependent variables are called independent variables, also called the predictor. The outlier. Outlier is an abbreviation which contains either very low values or very high values in comparison to other observed values. An outlier may hamper the results, so it should be avoided. Multicollinearity. If the independent variables are highly correlated with each other than other variables, then such condition is called multicollinearity. It should be not present in the data set because it creates problem while ranking the most affecting variable. Underfitting and overfitting. If our algorithm works well with the training dataset but not well with the test dataset, then such problem is called overfitting. And if our algorithm does not perform well even with a training dataset, then such problem is called underfitting. So why do we use regression analysis? As we mentioned previously, regression analysis helps in the prediction of continuous variable. There are various scenarios in the real world where we need some future predictions such as weather conditions, sales predictions, marketing trends, etc. For such case, we need some technologies which can make predictions more accurately. So for such case, we need regression analysis, which is a statistical method and used in machine learning and data science. There are some other reasons for using regression analysis. Regression analysis estimates the relationship between target and the independent variable. It is used to find the trends in data. It helps to predict the real or continuous values. By performing the regression, we can confidently determine the most important factor, the least important factor, and how each factor is affecting the other factors. So, the types of regression. There are various types of regression which are used in data science and machine learning. Each type has its own importance and different scenarios, but at the core, all the regression method analyzes the effect of the independent on dependent variables. Here are discussing some important types of regression, which are linear regression, logistic, polynomial, support vector, decision tree, random forest, ridge, and lasso regression. So first we discuss the linear regression. Linear regression is a statistical regression method which is used for predictive analysis. It is one of the very simple and easy algorithms which work on the regression and shows the relationship between the continuous variable. It is used for solving the regression problem in machine learning. Linear regression shows the linear relationship between the independent variable which is lie on x-axis and the dependent variable which is on the y-axis, hence called the linear regression. If there is only one input x, then such linear regression is called simple linear regression, and if there is more than one input variable, then such linear regression is called multiple linear regression. The relationship between the variables in the linear regression model can be explained using the above image. Here we are predicting the salary of employees on the basis of the years of the experience. You can see the graph of the experience and the salary. The mathematical equation for linear regression is y is equals to ax plus b. Here y is dependent variable which can be called as target variables, x is independent variable or predictor variable, and a and b are the linear coefficients. Some popular applications of linear regressions are analyzing trends in sales estimates, salary forecasting, real estate prediction, and etc. So now the logistic regression. Logistic regression is another supervised learning algorithm which is used to solve the classification problems. In classification problems, we have dependent variables in a binary or discrete format such as zeros or ones. Logistic regression algorithms work with a categorical variable such as 0 or 1, yes or no, true or false, spam or not spam, etc. It is predictive analysis algorithm which works on the concept of probability. Logistic regression is a type of regression but is a different from the linear regression algorithm in the term how they are used. Logistic regression uses sigmoid function or logistic function which is a complex cost function. This sigmoid function is used to model the data in logistic regression. The function can be represented as, you can see, f of x is the output between the 0 and 1 values, where x is the input of the function, is the base of the natural logarithm. So when we provide the input values to the function which we call data, it gives the S curve as you can see the figure. It uses the concept of threshold level. Values above the threshold level are rounded up to 1 and the values before the threshold level are rounded up to 0. There are three types of logistic regression, which is binary 0 or 1, pass or fail, multi, cats, dogs, lions, ordinal, low, medium or high. So now the polynomial regression. It is a type of regression which models non-linear data set using a linear model. It is similar to multiple linear regression, but it fits non-linear curves between the values of x and corresponding conditional values of y. Suppose there is a data set which consists of data points which are present in non-linear fashion. So for such case, linear regression will not be best fit to the data points. To cover such data points, we need polynomial regression. In polynomial regression, the original features are transformed into polynomial features of given degree and then modeled using a linear model, which means that the data points are best fitted in the polynomial line. And the equation for the polynomial regression are derived from linear equation. That means linear equation is equals to y is equals to b0 plus b1 of x. It is transformed into polynomial equation. You can see the model is still linear as the coefficients are still linear with coordinates. Support vector regression. Support vector machine is a supervised learning algorithm which can be used for regression as well as classification problems. So if we use it for regression problems, then it termed as support vector regression. So it is a regression algorithm which works for continuous variable. Here are some keywords which are used in support vector regression. Kernel, it is a function used to map a lower dimensional data into higher dimensional data. Hyperplane, it in general SVM, it is separation line between two classes, but in SVR it is a line which helps to predict the continuous variable and cover most of the data points. Boundary line, boundary line are two lines apart from the hyperline which creates a margin from data points. Support vectors, support vectors are data points which are nearest to the hyperline in the opposite class. In SVR, we always try to determine a hyperplane with a maximum margin so that the maximum number of data points are covered in that margin. The main goal of the SVR is to consider the maximum data points within the boundary lines, and the hyperplane must contain a maximum number of data points. Consider image. Here the blue line is called the hyperplane and the other two lines are known as boundary lines. Decision tree regression. Decision tree is a supervised learning algorithm which can be used for solving both classification and regression problems. It can solve problems for both categorical and numerical data. Decision tree regression build a tree-like structure in which each internal node represents the test for an attribute. Each branch represents the result of the test, and each leaf node represents the final decision or result. A decision tree is constructed starting from the root node or parent node, which is split into left and right child nodes, subset of data sets. These child nodes are further divided in three children nodes and themselves become the parent node of these nodes. Consider the uh, image showing the example of decision tree regression. Here the model is trying to predict the choice of person between sports car or luxury car. Random forecast is one of the most powerful supervised learning algorithm which is capable for performing regression as well as classification tasks. The random forecast regression is an ensemble learning method which combines multiple decision trees and predict the final output based on the average of each tree output. The combined trees are called as base model and then that can be represented as you can see. Random forest uses bagging or bootstraps. Aggregation techniques of ensemble learning in which aggregated decision tree runs in parallel and do not interact with each other. With the help of random forecast regression, we can prevent outfitting in the model and by creating random subset of the data. So the ridge regression is one of the most robust version of the linear regression in which a small amount of bias introduced so that we can get better long-term predictions. The amount of the bias added to the model is known as ridge regression penalty, which can compute this penalty term by multiplying with the lambda to the squared weight of each individual feature. The equation of ridge regression will be, you can see in the screen. So a linear polynomial regression will fail if there is a high collinearity between the independent variables. So, to solve such problems, ridge regression can be used. It is a regularization technique which is used to reduce the complexity of the model. It is also called as L2 regularization. It also helps to solve the problems if we have more parameters than samples. Lasso regression. It is the another regularization technique to reduce the complexity of the model. It is similar to the ridge regression except that the penalty term contain only the absolute weights instead of square of the weights. Since it takes absolute values, hence it can shrink the slope to 0, whereas ridge regression can only shrink it to near to the 0. It is also called L1 regularization. The equation for lasso regression will be, you can see on the slides.